We'll gradually increase the subdivision level for this cloth object and see its effects. The cloth looks like a hard surface with just one subdivision. If we increase the subdivision level to 2, we see some bending, but it's still not even close to how cloth should behave. It looks like a paper material at this level. With 3 subdivisions for our cloth, the bending is definitely better, but it's still just a paper material, maybe a thin paper but not cloth. If we increase the subdivision level to 4, for the first time we see some cloth-like behavior and a nice bending, but it's also not perfect yet. With subdivision levels set at 5, we see a good balance between stiffness and bending. Later we'll see how to control these parameters in cloth physics. Now we jump to 8 subdivisions for our cloth, and it looks like a tarpaulin or jeans. It's good, but we want more flexibility for a realistic effect. So if we double the subdivision level to 16, the real game starts. I would call it the absolute minimum for a realistic cloth. If we further double the subdivision to 32, the spongy effect or the bounciness of the cloth material gets even better. We can stop here, or we can go even one step ahead with 64 subdivisions. So we get our best output at this level, and the cloth looks perfect. Anything more than 64 will increase the baking and rendering time, with very marginal increase in quality, as we see here for 100 subdivisions. So 64 is our benchmark, and now we'll see how to create this animation. We can start with a plane for our cloth, and a cube which will fall on this cloth. In the edit mode, right-click on the plane and go to subdivide. We have to change the subdivision level from here. We'll go with 64, as we need a perfect cloth material. Then we have to assign these vertices at the 4 corners into a vertex group. So go to the Object Data tab and create a new vertex group. Now select the 4 vertices together while holding the Shift key and assign them into the vertex group with a weight of 1. Then back to the object mode, go to the Physics tab and enable Cloth Physics for the plane. We'll go with all the default values, but we'll customize the stiffness of the cloth, so expand the section called Stiffness, and you'll see a field called Bending, which will change to 0.1. This will allow the cloth to bend easily as the cube falls on it, and you can control it using this bending field. So the cloth property is done. Now under the Shape section, select our vertex group to pin the cloth at the 4 corners. Finally, expand the section for collisions, and enable the option of self-collision for a better cloth physics. Now for the cube, we won't use rigid body physics. We'll rather make it a soft body, because rigid body and cloth won't interact very well in this case. Let's change the mass of the cube to 5 kg. We have to actually make this soft body very rigid, so go down and disable the goal option. Then under Edges, turn up these 2 fields to the maximum level, but don't make them a perfect one, because that creates some instability. Then change this bending field to 1. This will convert the cube into almost like a rigid body, without using the rigid body physics, and that's the trick. We have to also enable the collision physics for the cube. It will enable proper collision between the cube and the cloth. And please note that the order of these physics modifiers is very important. This soft body physics should come before the collision physics. Similarly for the cloth, first the cloth physics, and then the collision physics should be added, which we can enable from here, again in the Physics tab. And another important thing is we have to animate a field called Distance, which is right here under the collision section. Within the cloth physics, it creates a better collision when an object falls on cloth. We have to stop where the cube comes close to the cloth object. So maybe we can go to frame number 45 for the first keyframe and change this distance field to 0.2 and insert a keyframe. Then go a few frames down the line like frame number 70 and slightly reduce this value to say 0.15 with another keyframe. Finally, go further down somewhere around frame number 200 and change it back to the default value, which is 0.015, and keyframe it as well. Now we have to bake our physics, so clear the existing cache and start the baking process. We can see the progress from here, and once it is complete, we can verify our result from the beginning. So here's the final outcome. You can further add a Catmull-Clark subdivision, along with Auto Smooth, which is a standard process for cloth. So I hope you like this tutorial. Thanks for watching, and don't forget to subscribe to this channel.